So we're going to take our talk of roots kind of one step further, and we're going to combine two ideas. We've been working with exponents, all those exponent rules, and then we talked about square roots. So the question might have come up somewhere in your brain, can you have an exponent that is not a whole number? And so we're going to tie our discussion of roots to exponents, and the answer is yes. There can be a rational exponent, that would be a 1/2, a 1/3, 1/4, a fractional exponent, and it's going to tie to a root today. So our objective is to connect those rational exponents to roots, and this picture kind of does it all. So I'm going to go on to the next page so we can focus on that. So basically, remember that we have a number under the radical symbol, which is called the radicand. We call this number in here the index, which was the invisible 2 for square roots. And today we're going to start putting some exponents in there, and we're going to change that index. So if you kind of come over here, you're going to see the 4 is your x, which is going to become the radicand. Don't notice that, we don't see an exponent on the 4, and notice that 1 up there. And notice that the number, the index is changing with the denominator. We're going to talk more about this, but this is the whole idea right here, that if you have a base raised to a rational exponent, the denominator becomes the index, the number that sits in the v, and the numerator is going to become the exponent of the radicand. Like I said, this is the whole idea. Let's walk through it and see what we got here. Okay, so we can extend the concept of square roots to other types of roots. For instance, so now I'm going to put a 3 in there. I'm going to take the cubed root, the third root. So no longer am I looking for identical twins. I'm looking for triplets. What number to the third power gives me 8? So 2 times 2 is 4 times 2. So can you see 3 factors of 2? So the cubed root of 8 would be 2. So when we write 2 to the third equals 8, if we put that 2 to the third root of 8 would give us back the 2. So cubing and taking the cube root undo each other. So in general, if you have some number raised to the n, 2 to the third, equaling a number, then that base, that 2, is the nth root of this number. So that 2 is the third root of 8. So if you take 2 to the third, you'll get 8. If you take the cubed root of 8, you get back to the 2. So that's the first thing we're going to talk about today, is we're going to change this index to other numbers other than 2. If it's a 4, we're looking for quadruplets. If it's a 5, we're looking for quintuplets, okay? And that's what we're going to talk about to start. So here's some examples. You got to be careful. You've got to notice that index is changed. So we're not looking for the number 8 here. We're looking for what number times itself equals 64. What number to the third power equals 64? Did you think 4? And you would be right. Now, Mrs. Woodruff, could it be a plus or minus? We're going to talk more about this on the next slide, but you see that 3? Think about it. So yes, it is 4, and 4 times 4 is 16 times 4 is 64. Now, what if we thought about negative 4? Negative 4 times negative 4 would be positive 16. And then if you multiply it by a negative 4, it would be negative 64, and that was not the radicand. So we are going to discover that when we have an odd index, an odd root, there can only be one answer. So now let's take a look at the cubed root of negative 125. And we talked a little bit about the square root. You can't take a negative. There's no number times its identical twin that will give you a negative number. A negative times a negative is a positive, and a positive times a positive is a positive. So when you have an even out here, you can't have a negative radicand. But can you have a negative radicand, a negative number under that root when it's odd? So now what I'm looking for is what number to the third power gives me negative 125. Is there such a number? Did you think, well, it ends in 5, so what about 5? So 5 times 5 is 25, times another 5 would be 125. But to get that negative, those triplets, that base has to be a negative, because negative 5 times negative 5 is 25. Multiply the 25 by another negative 5, and it would be negative 125. How about you try number 3? What is the fourth root? What number raised to the fourth power gives me a positive 16? So it's not 4. The square root of 16 is 4. But what number, quadruplets, there we go, would give me 16? And did you think 2 to the fourth? Now the question is, could you have a negative 2? And the answer, because this is positive and that is even, I could have either 2 or negative 2. Let's try number 4. So first of all, can I have a fifth root of a negative number? If that index is odd, that's an okay thing to do. Now I need to know what negative number raised to the fifth power gives me negative 32. Did you say negative 2? Positive 2 wouldn't do it. You wouldn't get the negative sign on the 32. So when you have an odd index like numbers 1, 2, and 4, you can only have one answer, one solution, one root. Those words are all synonyms. When you have an even index of a positive number, you can get 2 possible answers, 2 roots, 2 solutions. Okay, so let's go up and take a look at number 5. What do you think about that one? Did you kind of think something's wrong here? Okay, so what number raised to the fourth power would give me a negative 81? So first of all, did you come up with the number 3 to the fourth gives you 81? 3 times 3 is 9, times 3 is 27, times 3 is 81. Can it be a negative? Can we get a negative 81? Well, what about negative 3? Negative 3 times negative 3 is 9, times another negative 3 would be negative 27, times another negative 3 would be positive 81. There's no way with that even index to get a negative. This is undefined. Just like we can't take a square root of a negative number, any even index of a negative is a Okay, this one, don't forget, we've done these before. Remember that the index here is a positive 2. Since this radicand is positive, with that even, I can get an answer, and I will get 2. And this was sort of our last video. I just don't want you to forget our square roots. How about number 7? What would the fifth root of negative 1 be? Well, any root of 1 has something to do with 1. 1 times 1 times 1 times 1, right? And to get the negative, since this is an odd, you could say it would be negative 1. Okay, so number 8 is just the craziest problems that people get all caught up in. But basically, I need you to remember that a square root and squaring are opposite operations. A cubed root and cubing are opposite operations, sort of like the idea that I take a number, multiply it by 4, take that answer and divide it by 4, and I get right back to where I started. Those operations are opposite operations, and they undo each other. So square root and squaring undo each other. So this is just kind of a crazy problem that says if you take the square root of 5 and then square it, you're going to get right back to the 5. If you take 4 to the third and then take the cubed root, they undo each other. You get right back to the 4. So remember that opposite operations undo each other. Kind of the basis of a lot of equation solving we've done throughout the year. Okay, so I want to get to this idea of, can you have a fractional exponent that I showed you on that first slide? So I'm actually going to walk you through, this is the rule down here, but why? So what I'm going to do is I'm just going to start with the square root of 4 times the square root of 4, which would be 2 times 2, which is 4. Does everybody agree that that's a true statement? Do you see 2 factors of the square root of 4? So I'm just going to write that as the square root of 4 squared. And my question is, what kind of an exponent is the square root? That's what I'm trying to prove to myself. So I'm going to take that square out and say, what exponent? So I'm just going to replace that square root with an exponent of x. I'm solving for x to figure out what is that square root in terms of an exponent. Do you remember if you have a base raised to a power, you multiply? And notice that over here, the exponent is 2x, and on the right, the exponent is 1. They have to be equal because the base is the same. And notice that if I solve for x, I get 1/2. So basically, 4 to the 1/2 equals the square root of 4. So when you have an exponent that is a fraction, it's a rational number, the denominator is your index, what goes in the v, and the numerator is the exponent on the inside. Now, if you didn't understand this process, you can stop and take a look at it again. But then you're just going to kind of have to accept what I'm saying down here. So here's what I just said, that the square root of a is the same as a to the 1/2 power. The 2 comes out of the index, and that 1 is the exponent on the number underneath the square root. Here it is in general. Whatever that index is the denominator, and in all of these cases right now, that exponent is a 1. So the cubed root of a is a to the 1/3. The fourth root of a is a to the 1/4. So we're going to take that into some examples, but this was the screen I was going to tell you about that gives you all the idea of how many solutions there are, okay? So if you have a root that has n as an odd number, 3, 5, 7, it would look like either one of these. So like, say we had 27 to the 1/3, that would be the third root of 27. If we had negative 27 to the 1/3, it would be the third root of negative 27. And again, the numerator is your exponent inside. So what we just talked about is the cubed root of 27 would be 3 times 3 times 3. And the cubed root of negative 27 would be negative 3 times negative 3 times negative 3. So if you have an odd number, you can only get one answer. If it's positive underneath, it's the positive root. And if it's a negative radicand, it's the negative. You can only get one answer if your index is odd. Now for the next 3, we're going to talk about what if it's even. What if you have a 2, a 4, a 6, and 8? I'm going to use the number 16, for example. I'm going to use 16 to the 1/4. The denominator becomes your index. The numerator becomes your exponent. So this is the same thing as this, the 4th root of 16. What number to the 4th power gives me 16? And in this case, there are 2, positive 2 and negative 2. So 2 times 2 times 2 times 2 is 16, and negative 2 times negative 2 times negative 2 times negative 2 is 16. So there are 2 answers. So when n is an even number and the number underneath the radical symbol is positive, you'll get 2 answers. Now what if it's even and you have 0 under there? Well, the 4th root, the 6th root, the 8th root, to be honest, any root of 0 will give you 0. You get one answer because you don't have a positive and negative 0. The final one, if that root that is even, again, the index is even, and you have a negative, it's undefined. Now remember up here, if it's odd, you get an answer, but if it's even, it's undefined. So these are the 4 things that can kind of happen with different roots. Okay, so let's just do some examples, you and I. So the first one, let's just see if you can actually do this one. What is the third root of negative 125? So it's an odd of a negative, and that's legit. It's okay. And you will get one answer. Anytime it's an odd root, you'll get one answer. And did you get -5? Okay, so let's start talking about how to switch these around. This, I don't know what to do with this right now. So let's make it a root. Let's make it the fourth root of 16 to the first, right? So now it's an even of a positive. I expect to get two answers right now. So what number to the fourth power gives me 16? And it will be the positive and the negative. This is another way to ask the same question. Okay, so now they're giving you the index and they're giving you the radicand, basically. So you might want to, I think when we first begin, that's what they're asking, but you guys might be more comfortable writing it as a radical. So the n is the index and the a is the radicand, the number under there. So now it's an odd of a negative, what would your answer be there? Should have only gotten one answer. What number raised to the third power gives me -64? There's only one answer. Again, one answer when there's an odd root. Should have gotten -4. -4 raised to the third power is -64. How about if you try this one on your own? So I would have written it. I mean, that's what it's rational exponent. There's the base. The n becomes the denominator. The exponent on the 81 becomes the numerator, okay? And now you might prefer to see it as as a radical. So the 4 is your index of 81. So what number to the fourth is 81, or numbers? The minute I see that's even, I'm thinking, could there be two answers? This is positive, so I'm going to have two answers. What number raised to the fourth power is 81? And it would be plus or minus 3. 3 to the fourth is 81. -3 to the fourth is 81. So kind of where we need to go now is say, well, can we ever have something that has a number other than 1 in the numerator? So like 3/2 or -1/2 can also be exponents. So here again, I'm going to go through a couple of examples with you, and then we'll do a couple. So what if we had a to the m/n, right? So that's the same thing as a to the 1/n m. This guy we just said will be the nth root of a, and then we're going to raise it to the mth power. Boy, that's hard to say. So let me just take 16 to the 3/4. I think it's easier to see once we do a number. We're going to write this as a root. So I put my root sign. The number in the denominator becomes the index. The number in the numerator becomes this guy's exponent. Now listen to what I'm about to say. It is always easier to make something smaller before you make it bigger. So you could do it in this order. You could take 16 to the third, and you're going to get a big number, and then you're trying to figure out what's the fourth root. So don't do that. What you're going to do is make it smaller by taking the root first and then raising it to the third power. So when I take a look at the fourth root of 16, I realize that I'm going to get two answers because it's an even of a positive number. What number to the fourth gives me 16? It would be 2 or -2. And now I'm going to raise that to the third power. 2 to the third is 8. -2 to the third is -8. So 16 to the 3/4 power is plus or minus 8. What if we had a negative rational exponent? It's like this one, 16 to the -3/2. Do you remember that a negative exponent will reciprocate and go to the other place and become a positive exponent? Okay. Now I have 1 over, and remember, I'm going to take the bottom root before I take the exponent. So I'm going to take the square root of 16 and then raise it to the third power. The square root of 16 is 4 or negative 4. And then I'm going to raise it to the third power. 4 to the third is 4 times 4 is 16 times 4 is 64. And negative 4 times negative 4 times negative 4 is negative 64. So this is just plus or minus 1 over 64. So the bottom number, the denominator in the rational exponent becomes your index, and the top number becomes the exponent. But always take the root before you raise it to that power, or you end up with a kind of a big number you don't know what to do with. So let's do a few together. Let's see if you can actually write number 5. Try it yourself right now. So the first thing I would have done is I would have written it as a root. So I'm going to take the bottom number would be the index, so the square root of 9, and then raise it to the third power. Oh, the square root of 9 is 3 or negative 3, and then I have to raise it to the third power. Be careful, it's not 9. 3 times 3 times 3, 27, and it's plus or minus. So the next one is the same problem. Don't let this negative freak you out. It's just going to put that negative, you're going to reciprocate it and become a positive exponent, which we learned our first exponent rule of this unit. And now the 5 is going to become the index, and the 2 is going to become the exponent. So I'm going to take the fifth root of 32 and then square it. Now this is an odd, guys. Odd, odd, odd. One answer. So what number to the fifth gives you 32? And then I'm going to square it. Final answer, 1/4. And finally, when we get down here, we have the root of 4 to the 4th. Remember that you can take the root first. They're kind of on the same order because they're both exponents, really. So you can take whichever one you want first. So I would take the square root of 4 and then raise it to the 4th power. So the square root of 4, oh, I lied. Let me do that first, though. The square root of 4 is 2, and then, or negative 2, and then I would raise it to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. There is another way, which I wanted to show you using the exponent rules, I just forgot, is remember that this is the 1/2 power. And if you raise a base to a power, you multiply these two and you get 4 over 2, which is squared. So there is more than one way to kind of get to that answer, and you just got to go with your comfort zone. So if I write that as my rational exponent and then a power to a power, you multiply 4 times 1/2 is 2 and square it, you can get there that way as well. So we're going to finish one last idea is, where do we use this algebraically? Well, our equations sometimes can come in with exponents. And that's kind of where we're going to work with right now is how would I solve this for x when I've got a 4th power? The first thing that you need to do is to solve for the variable. So in other words, how do I remove multiplying by 2? That was the same a long time ago. We're going to divide both sides by 2. So on this side, I'll get x to the 4th, and when I divide over here, I get x to the 4th equals 81, 162 divided by 2. Now, my question is, what number to the 4th power gives me 81? So I'm looking for, basically, the 4th root. So to undo the exponent of 4, what if I took the 4th root of both sides? Because that would undo the exponent of 4. So these two undo each other and give me x. And the question is, like I said, what number to the 4th power gives me 4, or numbers? And did you think 3? 3 times 3 is 9, times 3 is 27, times 3 is 81. And because this is even and this is positive, the negative 3 works as well. Here's the cool thing. We can check our answers back in that original equation. So does 2 times 3 to the 4th equal 162? Does 2 times negative 3 to the 4th equal 162? And here are my checks. So 3 to the 4th is 81, and 2 times 81 is 162. Yay! Negative 3 to the 4th is also positive 81, and 2 times 81 would be 162. And so I have 2 solutions to that original equation. I'm just going to let you know when you get to Algebra 2, they'll talk about the fact if there's an exponent of 4, there are 4 solutions. There are 2 real solutions and 2 complex solutions. More on that in the future. We're not worrying about it. Right now, we're looking for just real number solutions. All right, over here, guys. How about if you try this one? Think about it. See if you can do it, and I'll come back and do it with you. So the first thing I said was, how do I get rid of this exponent of 3? And what I would have done is taken the third root of both sides. The cubed root and the exponent of 3 are going to cancel each other out, and I'm going to get x minus 2. And the cubed root of 125, odd of a positive number, you're going to get one answer. 5 times 5 times 5 gives you 125. And look at, guys, we're at a wicked easy one-step equation. We're going to add 2 to both sides, and we get the answer x equals 7. Do you believe it? Well, let's check it. Put 7 back in the original for the x. Do you get 125? Well, 7 minus 2 would give me 5, and 5 to the third is 125. So we can actually solve much more complicated equations understanding how roots undo exponents. So really what we need to do is just practice this idea, and I'm hoping that you just get the feeling that there are roots other than square roots, that there is a tie between an exponent and a root. That would be a rational number, a fractional exponent can tie into a root. And that's really what we were talking about today. We were using that idea to simplify expressions, and then we actually solved equations using exponents other than 1 on our variables. We'll keep practicing. Now you're going to get a worksheet to practice. We'll go over it in class, practice some more. Have a great day, everybody.